Hello friends, in today's video we are going to study about these two algebraic identities, a plus b the whole cube and a minus b the whole cube. So first of all, let us start with a plus b the whole cube. Now how do we derive the formula for a plus b the whole cube? Now a plus b the whole cube can be written as a plus b the whole square times a plus b, right? So now we know what is the identity for a plus b the whole square. That is nothing else but a square plus 2ab plus b square, right? And then a plus b as it is. Now what we are going to do? We are going to multiply all the terms in these two brackets. So first of all, let us start with a square. So a square times a, it will be a cube. Now a square times b, it will be plus a square b. Now we will multiply 2ab with both of these terms one after the other. So it will become 2ab times a. So it will become 2a square b. Now 2ab times b, it will become 2ab square, right? Now we will multiply b square with both of these terms. It will be ab square. Now remember, you can write down b square a also. It is one and the same. But we are trying to keep a first and then b so that we are able to simplify this in easier way. In the last term, it will be b square times b. It will be b cube, right? So now a cube, only one term. So we will keep a cube as it is. Now plus a square b, how many times it is there? 1. And here it is 2. So that means total it will be 3a square b, right? Plus now ab square term, how many? 3 are there. So 3 times ab square plus b cube. So this is the formula to calculate a plus b the whole cube. A cube plus 3a square b plus 3ab square plus b cube. Okay. Many people write this also as a cube plus b cube plus 3ab times a plus b. Okay. A cube plus b cube you can easily remember from here, right? That take cubes of both the terms. Then plus it is, because it is cube, so you can remember it like this also, that 3ab, whatever are the terms, multiplication of that. And in the bracket, the summation of both the terms. Okay. So you can apply this way or this way. It is the same formula. Okay. But you can remember this way easily. So now this is about algebraically. Can we prove this formula geometrically also or not? Let us check that. Why we are trying to do it geometrically? Because remember, it is cube, right? A plus b the whole cube. Means there has to be some relation between the formula to calculate volume of a cube. Okay. So that is why we will try to prove this result using a cube whose each side measurement it is a plus b. That is why here it will be a plus b, here it will be a plus b, here it will be a plus b. Then the formula to calculate volume of this cube, it will be a plus b the whole cube. So here we have taken a cube whose dimension it is a plus b, right? That is why here the length is a plus b, breadth is a plus b, and the height is also a plus b. That is why the volume of this cube will be a plus b the whole cube. So now let us separate out all of these cubes and cuboids and see how can we derive the formula of a plus b the whole cube. So let us look at its animation. So here, when we separate out all of its components, then this component or this cube has dimensions a, and a, right? That is why its volume will be a cube. This cube has dimensions b, b, and b. That is why the volume of this cube, it will be b cube. Now here, if we look at these three cuboids, then the measurements are the same. Here it is b, then a, here it is a, and b, here it is a, b, and a. What is happening here? It is they are the same cuboids, only we have rotated them at different angles. Okay, that is why. But the volume of each of these cuboids, it is going to be a square b, right? And because there are three cuboids, so their summation, it will become 3a square B. Now, similar way, here also there are 3 cuboids, and if you compare their dimensions, then they are also same. Only we have rotated them at different angles. So, volume of each of these cuboid, it will be what? B times A. That will be B square A, right? And because there are 3 cuboids, so their total volume, it will become 3B square A, right? And this is what we had already seen, that this is the formula, or this is the algebraic identity to calculate A plus B the whole cube, right? This is the expansion of A plus B the whole cube. This is what we had already seen algebraically also. And this is how we can provide its visual proof also. Now let us see if we have any values of A and B, still this algebraic identity is true or not. So here, from the sliders of A and B, we have different values of A and B. When we substitute those values here in A plus B the whole cube, after simplification, we will get some value, right? And when we substitute the value of A and B here also, we will get some value. So comparing 1 and 2, we can clearly see that the values are coming to be equal. That means these two are also equal, right? So from results 1 and 2, we can say that this algebraic identity is valid, or it holds true for the values of A and B. And of course, you can change the value of A and B also, and still you can see that this identity always holds true. And if you want to look at the components or the cubes or cuboids which make this cube, then you can rotate this around and also see, right? Like this cube is representing B cube. This green cuboids, they are representing AB square. And this pink ones, they are representing A square B, right? And if you want to increase the size also and look at it in a better way, then this is how you can do it, right? So this is how we can prove this identity algebraically, and visually also we can see that this is how A plus B the whole cube will look like. And these are all the components that make A plus B the whole cube. Now let us derive the formula to calculate A minus B the whole cube. Now A minus B the whole cube, it can be derived in two ways. Either you can multiply A minus B the whole square with A minus B. Okay, so let us derive it both the ways. So here, what is the formula to calculate A minus B the whole square? It is nothing else but A square minus 2AB plus B square times A minus B. So as we did for A plus B the whole cube, let us multiply all these terms. So the first term, it will become A cube, then it will be minus A square B, then it will be minus 2A square B, right? Now minus this will become plus 2AB square. Now we will multiply B square with both of these terms. So it will become AB square minus, it will be B cube, because here it is plus, here it is minus. So plus minus, it will become minus. So this can be written as A cube. Now here A square B, this is also A square B term, and this is also minus, this is also minus. So minus minus, it will become plus. So minus 1 minus 2, it will become minus 3. So minus 3 A square B. Now these two are plus, so we can add them out. So it will become plus 3AB square minus B cube. So this is how we can derive it. And of course, we can write this down as A cube minus B cube minus 3AB times A minus B. So this way also you can remember it out. Okay, it will become A cube. Now because here there is a minus sign in front of B, so here it will be minus B cube. Because there is a minus sign in between, so here also it will become minus 3AB times the terms A minus B. Now the other way by which we can derive this formula, it is we can write down A minus B the whole cube as A plus minus B the whole cube, right? And we know the formula for A plus B the whole cube. That is nothing else but we can write it down here. A cube plus B cube plus 3AB times A plus B. So wherever it is B, let us replace it by minus B. So A cube will remain as it is. Now this will become minus B whole cube plus 3A times minus B. Here it will become A minus B. So this can be written as A cube Now what is the cube of minus? It is nothing else but minus. So minus b cube. Now plus minus, it will become minus 3ab times a minus b. So if you know the formula to calculate a plus b the whole cube, then you can just substitute b by minus b and derive this formula. Or you can remember it this way also, right? So this is how we can algebraically derive the formula to calculate a minus b the whole cube. Now let us see if geometrically also or visually also can we prove this or not. So here now we have taken a cube whose volume it is a cube, means each side measurement it is a, and in that we have taken this much of length to be b. So how much is this going to be? Total is a, this much is b, so this pink one it is going to be a minus b, right? So that is how we can define each dimension. Okay, now let us look at its animation. So here we have separated out all the components. Now we are interested in finding the value of a minus b the whole cube, right? And this left hand side it is a cube. So that is why here when we separate out the components, this cube will have the dimension of a minus b, a minus b and a minus b. So the volume of this cube, it will become a minus b the whole cube, right? The volume of this cube whose dimensions are b, b and b, it will be b cube. What about these three cuboids? Now if you compare the dimensions, they are the same. Here it is a minus b, b and b. Here it is b, a minus b and b. Here it is b, b and a minus b. If we rotate one of them, then we will get the other cuboid, right? So the volume of each of these cuboids, it will be what? A minus b times b square. But because there are three, the summation will give us 3b square times a minus b, right? And similar way, if we look at these three, then the dimensions are again same. If we want to find the volume of each of them, then it will be what? B times a minus b the whole square. Because there are three, so that is why the total volume it will be 3 times a minus b whole square times b. So from here we can write down a minus b the whole cube is equal to, we can take all of these terms on this side. So it will become a cube minus b cube minus 3 times b square times a minus b minus 3 times a minus b the whole square times b. When you simplify this out by opening out the brackets, then this is the value that we will get. A cube minus 3a square b plus 3ab square minus b cube. Okay. So this is how we can provide the visual proof of a minus b the whole cube also. Now let us see if this algebraic identity holds true for any values of a and b or not. Let us check that. So here we have different values of a and b. A is given to be 4.9 and b it is 3.5, right? When we substitute all the values here, we will get what is the value of a minus b the whole cube. And when we substitute the values of a and b here in this right hand side of the identity, then we will get this value. And from 1 and 2, we can easily see that the values of the left hand side and right hand side, they are coming to be equal, right? This means that this identity holds true for any values of a and b. So this is how cube of a will look like. Okay, and of course you can change the values of a and b also and see that, right? For better view, you can increase the size also and you can understand it from here. So this whole length it is a. From that b is 2.1. Okay, so here this pink cuboids are representing one value and this light green ones are representing another value, right? And the summation of all of these will come to a cube. So this is how we can derive the formula to calculate a plus b the whole cube and a minus b the whole cube. So I hope you were able to understand both of the algebraic derivation and their visual proofs also. In the next video, we will solve some questions based upon these algebraic identities. Thank you so much.